Thanks for sticking around. I know this has been a action-packed 2 days, so thanks for sticking around to the end here. I'm excited to be talking to you about turbo machinery for hydrogen applications. My name's Daniel Patrick. I'm the hydrogen and carbon capture application manager at Atlas Copco Mafi Trench in California. Let's jump into it. So you guys might already be familiar with Atlas Copco, but we'll first start with a little introduction to who is Atlas Copco and what our mission is, and then we'll jump into the different turbo machinery applications for the entire hydrogen value chain, and that primarily is going to be blue hydrogen production on the carbon capture side, hydrogen liquefaction, and then handling of that liquid hydrogen boil-off gas. And then at the end, we'll kind of talk specifically about the challenges with hydrogen and turbo machinery. Okay, so Atlas Copco is a decentralized group with 4 business areas. And within those 4 business areas, there's 23 total divisions. So quite a large company. We fall into the compressor technique business area under the gas and process division. That's the custom engineered turbo machinery portion of Atlas Copco. And we're not the only division within Atlas Copco who's really focused on hydrogen. There's a ton of interest within the company to help drive the energy transition. Specifically, our colleagues in the oil-free air department or division are providing reciprocating compressors, filtration units for the hydrogen industry. So if that's of interest to you, please come by our booth. But the topic of my presentation is turbo machinery, so we'll stay on that topic with the gas and process division. So the gas and process division has 7 product companies within Atlas Copco spread throughout the globe. So let's see if I can get all these out here. So there they all are. So there's 3 in North America. I'm coming out of Atlas Copco Mafi Trench in California, where our core competency is the turbo expander portion of the business. Each product company has a kind of a specialty or core competency, but it allows us to do local packaging, anywhere in the world to fit that local market. Okay, so that was our quick intro to Atlas Copco. So let's jump into the turbo machinery applications for hydrogen. So the 3 main applications I'll be covering today are carbon capture applications. So we're very excited to help contribute to decarbonizing existing hydrogen production, which is primarily gray, and that existing infrastructure can be turned to blue, to low carbon hydrogen via carbon capture, utilization, and storage, and our CO2 compressors really enable that. Next, hydrogen liquefaction is a key portion of the hydrogen value chain to enable effective transportation of hydrogen. So we provide the turbo machinery as part of that refrigeration process, so the refrigeration compressors and the cryogenic turbo expanders that provide the cooling. And lastly, once you have that liquid hydrogen, you have to be able to handle that boil-off gas. So we do offer boil-off gas compressors for liquid hydrogen, so we can recompress that hydrogen for further use, either liquefying it or for fuel for a ship, a carrier. I always like to show this slide, partly because I'm a fan of turbo expanders. That's kind of my specialty. But not everybody knows what a turbo expander is. Everybody kind of, you have a good understanding of a compressor, but what's a turbo expander? So you can think of it kind of like a valve. It's expanding gas, providing cooling. But the cool thing about a turbo expander or expansion turbine is that you get so much more efficient cooling. it's a near isentropic process to extract the work out of that gas. So you get so much more refrigeration out of a turbo expander. And that's just one benefit. You also get this shaft power. So you actually get mechanical work coming out of that turbine. So yeah, we'll talk a little bit more about how that's used in the cryogenic processes I'm going to get into. Okay, so let's talk about carbon capture applications. You know, on the turbo expander side, there are cryogenic applications within carbon capture, known as cryogenic carbon capture or low temperature carbon capture. And like I was just mentioning, the turbo expander can provide that refrigeration to help separate the CO2 from the process. And of course, once you have that CO2, you need to compress it, send it either underground to a pipeline, and that's really it's a core competency of Atlas Copco, these CO2 compressors. So you can see there on the slide the CO2 compressor, up to 8 stages of compression on a single gearbox, and it's quite a nice solution to send a large volume of CO2 to either be sequestered or used somewhere. Okay, moving on to hydrogen liquefaction. So you guys are all probably familiar with how cold you need to get hydrogen to liquefy it. Minus 253 degrees C, it's quite cold. So how do we do that? You use a refrigeration cycle. Quite a large refrigeration cycle to do the medium and large scale liquefiers that we will need for the energy transition. So these are centrifugal compressors for the pre-cooling cycle, nitrogen, mixed refrigerant compressors. This has been a core competency for Atlas Copco for decades. And then, of course, the expansion turbines provide the refrigeration to provide the cooling. So here's another kind of depiction of the compressor, the refrigeration compressor on the left there. This is motor-driven centrifugal compressor, multi-stage for nitrogen pre-cooling applications. And typically these are, it's a separate compressor and then a separate turbo expander. But we also can offer these stages all combined on a single gearbox called a compander. And that's been very successful in the LNG industry, where you have the compression and the expansion all in a single machine. It's quite an elegant solution for the pre-cooling cycles of hydrogen liquefaction. Oops, here we go. So this is where really the state of the art happens. The lowest temperature cryogenic application for turbo expanders here, the cryogenic hydrogen turbo expanders. So our solution is to provide magnetic bearings, which is unique, I think, in the market. Most small scale liquefiers have used smaller gas bearing turbo expanders, and the magnetic bearings really allow us to remain oil free, so there's no possibility of oil contamination of your process piping or heat exchangers, but allows to be larger scale. So I think people keep talking throughout the conference that it's all about scale to really find those commercial savings and be more cost effective. And so magnetic bearings really allow you to reach those large-scale liquefier economies of scale without adding new machines. These machines can really just grow. Another benefit is there's no loss of any refrigerant with magnetic bearing solution. These can either be compressor or generator loaded and have variable inlet guide vanes, so they can adjust the liquefier process conditions to fit the production of the hydrogen. So good turn down and off design performance. So I won't spend too much time on this, but just want to mention that we've been doing magnetic bearing turbo expanders for over 30 years, so this is not new in hydrogen-rich processes. So again, hydrogen is not new to us, and we have over 10 million operating hours with this technology. So quite experienced with this magnetic bearing solution, rotating equipment. Okay, so the last application I'll touch on is the liquid hydrogen boil-off gas compressor. We were very happy and proud to be a part of the Hystra project with Kawasaki Heavy Industries, the first liquid hydrogen carrier ship, and provided the boil-off gas compressor for that project. So this is it's a cryogenic minus 253 degrees C integrally geared compressor, and in the future the boil-off gas could even be used to power the vessels. So certainly an exciting application for our technology. Okay, so we'll just briefly talk about a few challenges with hydrogen and how we're addressing those. So with turbo machinery, mole weight really has a large effect on the impact of aerodynamics. So the heavier or lighter the gas, it really changes the aerodynamics. So I like to think of it like throwing a baseball. Here's the analogy. So I was talking about CO2 earlier, carbon dioxide. It's a very heavy molecule, and it fits well within turbo machinery. It's kind of like throwing a baseball. I'm from the U.S., so hopefully you guys are following me with the baseball analogy. So yeah, you can throw a baseball, 100 yards, pretty good distance with a single throw. But with lighter molecules like hydrogen, the lightest molecule, is more like throwing a ping pong ball or something, a wiffle ball, where you throw it and it's not going to go very far. It's just super lightweight. And so it's challenging for turbo machinery for that reason. Because lightweight molecules, we have higher enthalpy per stage. So, or higher enthalpies, which requires more stages. So really the effect is you either need to go faster or you need to add more expansion stages for hydrogen. And that's true for turbo expanders or centrifugal compressors. So of course there's efforts to increase tip speeds, be able to go faster, and I think all the OEMs for compressors are looking into that, and I think it's something that we can address with some further R&D, but hydrogen really is, it will require more stages and is challenging for turbo machinery for that reason. I think I'm almost out of time. A few more technical challenges. I just mentioned aerodynamic optimization, the low temperatures, material selection with hydrogen embrittlement. These are all things that our engineering team has addressed, and we're able to mitigate these risks for these applications. I think I'll skip that slide and just go to the end. So we're really looking forward to collaborating with EPCs and process designers in liquefaction, carbon capture, and the boil-off gas applications. So I think turbo machinery plays a really important role in the hydrogen value chain, and yeah, we're ready. So I hope you'll visit us at our booth if you have any questions on my presentation, and really thank you for your attention.